Right now, our night sky is changing quickly, and in simply a question of many years, if not sooner, it could become completely unrecognizable. Astronomers around the world are sounding the alarm. Experts like Neil deGrasse Tyson have recently confirmed the inevitable explosion of Polaris, and the story behind it is quite terrifying. Polaris, known as the North Star, has long been a constant in our night sky, serving as a crucial reference point for stargazers, pilots, and astronomers alike. However, this could soon change, altering our night sky and cosmic measurements forever. Let's delve into the significance of this threat and its implications for us all. Join us as we uncover the tale of Polaris as it moves toward its end. For ages, Polaris has guided sailors and astronomers alike, holding a revered position as a guiding light. Its steadfast presence in the night sky has been fundamental for navigation, yet this stability may soon be disrupted. In September 2023, a research paper presented by the respected Royal Astronomical Society cast doubt on the fate of the celestial illuminator. Polaris is on the verge of exploding, possibly disappearing from the night sky forever. Before we explore the consequences of this discovery, let's learn more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned directly above Earth's North Pole, it appears almost stationary in the northern sky. Found in the constellation Ursa Minor, or the Little Dipper, Polaris shines as a moderately bright yellow-white supergiant star, much larger and brighter than our Sun. It is not a solitary star but part of a complex triple star system, with Polaris AA and Polaris AB forming a binary pair while Polaris B orbits around them. The interactions among these stars create gravitational forces that shape their orbits and influence their behavior. Any disruptions in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these connections remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey more than 3 centuries ago. Therefore, if Polaris were to explode now, we wouldn't observe it until more than 3 centuries later. It's even possible that Polaris has already exploded, and we are yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its stability and fixed position made it an invaluable guide for ancient sailors, guiding them across seas and lands. Symbolically, Polaris represented consistency and direction, remaining steadfast amid the ever-changing night sky. For astronomers, Polaris served as a crucial reference point, aiding the study of stellar motions and variable stars. As a Cepheid variable star, its periodic variations in brightness have provided significant insights into stellar properties and the nature of variable stars. This characteristic also played a vital role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, making it easy for us to anticipate its behavior. However, recently, Polaris has deviated from this normal behavior. This irregularity in its pulsation cycle has puzzled astronomers, prompting a closer examination of the celestial phenomenon. Rather than its usual predictable pattern, Polaris has begun displaying erratic cycles of dimming and brightening. Scientists are now raising concerns that the star may be nearing the end of its life. This aligns with behaviors typically observed in stars approaching their end. The gradual expansion of Polaris' pulsation period, which was once steady, can be attributed to interactions within its star system. We've observed an annual increase in the pulsation duration of 4 to 5 seconds, which may seem minor but holds significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these fluctuations in its atmospheric conditions, directly affecting its pulsation patterns. However, others are more alarmed, believing that the star is on the verge of exploding. The similarities between Polaris behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited perplexing anomalies in their luminosity, raising concerns about potential explosions. Cepheid stars in their twilight stages often display such irregularities before reaching the climax of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention hasn't officially been directed toward Polaris yet. As a Cepheid star approaches the end of its life cycle, it progresses through various stages, including the main sequence stage, red giant stage, and ultimately the supernova explosion. Based on Polaris' irregular pulsations, scientists predict it has entered the stages of helium depletion, typical of Cepheid stars nearing their end. These anomalies in Polaris behavior align with patterns characteristic of Cepheid stars in their twilight stages, though definitive signs of its impending supernova remain uncertain. Astronomers are continuously examining these abnormalities to determine Polaris' fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, potentially outshining the Moon. Furthermore, becoming one of the most splendid articles noticeable for days, weeks, or even months, its appearance could definitely change, briefly modifying our view of natural heavenly bodies like the Big Dipper or Ursa Minor, of which Polaris is a part. Have confidence. The Earth would probably be entirely protected regardless of whether Polaris were to detonate. Given its mass and distance from us, while a Polaris blast probably wouldn't be as outwardly fantastic as that of Betelgeuse, it might still be visible to the unaided eye for an extended period and overshadow nearby stars. Astronomers and observatories would undoubtedly take notice, sparking intrigue within the scientific community and among stargazers overall. Anyway, the particular visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing. While giant stars typically end their lives with a supernova, this is unlikely to be the case with Polaris. When a massive star goes supernova, a tremendous explosion occurs within it, marking the final catastrophic stage of its life. This process involves a complete core collapse, triggering an intense shock wave that causes the star to explode violently. However, Polaris isn't massive enough to undergo such an explosion. Rather, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't result in a supernova but rather a quiet end as it evolves into a small, incredibly dense celestial remnant. A white dwarf is the remnant of a low or medium-mass star that has exhausted its nuclear fuel. It's extraordinarily dense, possibly as massive as the Sun but compressed to the size of Earth. When this happens, we will no longer be able to see its remnants from our planet, much as we observe the star today. Examining the potential effects of Polaris's overflowed with historical supernova events offers invaluable insights into the evolution of stars and their ultimate fates. Comparing our expectations with documented supernovae like SN 1054 or SN 1987A and recent events, such as SN 2011 Fe or SN 2014 J, provides valuable data for understanding the possible aftermath of Polaris's outburst. SN 1054, for example, resulted in the formation of the Crab Nebula, a nebula that continues to expand and emit radiation across many wavelengths, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into the processes of nucleosynthesis and the dynamics of supernova remnants. Analyzing phenomena such as the formation of nebulae, the release of cosmic rays, and variations in luminosity can offer insights into Polaris's unique characteristics. The formation of nebulae like the Crab Nebula results from the expulsion of material during the supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Moreover, the release of cosmic rays, high-energy particles accelerated by the supernova shockwave, has implications for astrophysical processes and cosmic radiation environments. To make a definitive analysis, scientists assess differences in mass composition and velocity of ejected materials between Polaris's potential burst and other observed events. This involves studying the light curves, spectra, and remnants from these events and extrapolating similar characteristics for Polaris's potential burst. Evaluating whether Polaris's burst could lead to the formation of nebulae or distinctive elemental distributions enhances our understanding of its possible outcomes. Another critical area of research involves assessing the pulsational variability of stars nearing their end stages, similar to Polaris, against observed supernova progenitors. This comparative study can help identify similarities or deviations and provide insights into the explosion mechanism. Pulsational variability in stars nearing the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the evolutionary processes leading up to supernova explosions. Despite thorough observations and extensive analysis, astronomers find themselves puzzled by the anomalies observed in Polaris's behavior. Unraveling the unique circumstances driving these inconsistencies holds the key to advancing our understanding of stellar evolution. Understanding the mechanisms responsible for Polaris's erratic pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a primary reference point in the night sky presents significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of astronomical assessments. The absence of Polaris could also impact navigation systems and cultural practices based on celestial landmarks, underscoring the significance of this cosmic event. The enigmatic behavior exhibited by Polaris highlights the need for deeper investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding its irregular pulsations and present concrete answers, recognizing the importance of advancing our understanding of celestial intricacies. Ultimately, the answer to Polaris's fate remains uncertain, and only time will reveal its true nature. Nevertheless, the pursuit of knowledge and understanding in the face of cosmic uncertainty is a testament to humanity's enduring curiosity in unraveling the mysteries of the universe.